All right, so we're looking at a few sections of chapter 9, and as you can see, this is multiplying, dividing rational expressions, algebra. So rational expressions are fractions, so it's algebraic fractions. We even see here we've got some complex fractions that we're going to deal with. So a rational expression is a ratio, that's why it's a fraction, of two polynomial expressions, and a complex fraction is basically going to be a fraction whose parts are fractions. You did those in elementary school with arithmetic, but we'll see them a little bit here today with our algebra. In some previous work we did about a month ago, I guess, maybe 3 weeks ago even, we looked at things like this. And one obvious thing here, because these are already in factored form, this is, by the way, rational expression, it's a fraction, it's a ratio, comparison of two polynomials. But one obvious thing here is that the y plus 7 will cancel. It's already in factored form. Well, actually this is not factored. But that somebody had already factored some at least. And so those would cancel. Now I could, somebody go ahead and write that. I could factor that denominator because it's the difference of squares. But when I do, I'd get 3y over, you know, Al's winking at you, signs are different, like an Al winking at you. So it'd be y and 3, but there's no canceling that can be done. So really this is our best answer here. But that was already in factored form. If it's not in factored form, you got to provide the factoring. So you can see here that the work they've done is the same. The answer is the one we got without factoring the denominator difference of squares. If it would have canceled, that would have been great. Now this is a really good question. It says, under what conditions is the expression undefined? Again, we've talked about this, so this is a lot of this stuff is not new. They're just kind of pulling it together, and we're going to do some really cute algebra here in chapter 9. Really cute algebra. But we talked about what makes a fraction undefined, and that's when the denominator is 0. So that's the question. When would y plus 7 times y squared minus 9 equal 0? Because when that happens, it's undefined. Okay? So that's our question. When does that happen? When does it happen? Well, to carry this out a little further, we've already said what the factoring of that difference of squares would be. And so Al's winking at us with the y and the 3, the y and the 3. Now, I can finish this out with a zero product property because this is multiplication, this is multiplication. And so I could say, when you're multiplying, get a 0 in the answer, one of the factors has to be 0, there are 3 of them. Or I could kind of look beyond that and some things that we did before. What would make that 0? A negative 7. What would make that 0? A negative 3. What would make that 0? A positive 3. Those things are the things that can't be. That's when it would be undefined. So x can't be that, nor that, or in this case y. Can't be that, nor that, because those are the things that would make it undefined. And you can see that's what they got here. The negative 7, the negative 3, and the positive 3. Same 3 values we had. You could have written that as negative 7 and then positive negative 3. Same answer, just semantics here. So they want us to simplify this. Well, as we saw in that other example, you know, these will cancel easy, obvious. It was already factored, it can be done. This is the difference of squares. It'd be great if you could cancel with that some way, but you can't. So really, that's the answer, x over the difference of squares, which is the B answer. And then they're going to come back and ask us the same thing they did in the previous problem, and that is, when is this undefined, this expression? Well, it's undefined when the denominator is 0. So one place would be at negative 5, right? That would make the denominator 0. So one of the answers has to be negative 5. Let's see what the D answer is. It's just negative 5. But the other answers would be evolving around this part. When would that be 0? And you know, if you factor that, the difference of squares is x plus 4, x minus 4. So it would be 0 at negative 4 and positive 4. So you already had the negative 5, making the correct answer C. And if that's too fast, rewind the video. Answer C. So here's another problem not in factored form, where they ask us for the undefined values. Do we care about the numerator being 0? No, we don't. I mean, we care, but we don't in this question. Because when they say undefined, they're talking about what would make the denominator 0, because that's not defined. You know, it's illegal. You can't divide by 0. So the question is, when is this equal to 0? You know, when does that happen? Because that's where it's undefined. Undefined means that P can't be that, because if it was, it would make the whole fraction a division by 0 fraction, and you can't do division by fractions, or division by zeros. So here you got a factor. You know, is there a GCF? No. Is there a special case? Well, if it's a trinomial, that would be a perfect trinomial square. That's a square. That's not a square, so that's not it. But the leading coefficient is 1, so it's double bubble. P and P. Signs are different. And then we have the factors of 15 whose difference is 2. And I hope you see it would be 3 and 5. The question is, who's the positive guy, who's the negative guy? You know, to give me the negative 2, it would be that one. So that's how you know this and this. And then you apply the zero product property, or you just kind of look and have some insight and say, well, P can't be negative 3, because that would make that 0. P can't be 5, because that would make that 0, making the answer B. Question. Making the answer B. Okay. So we could do more. We could, you know, it's a factoring thing. It's a denominator being 0. We could do more of that. We can see that. I want to remind you of something that we talked about in Algebra 1. And that's this particular algebraic fraction. These two things here are inverses. You know, like when you were in elementary school, you found out that these two are inverses. And when you divide, you get negative 1. These two are inverses. When you divide, you get negative 1. This is what you get. So that's what you get here, because these are inverses. Because here the x is positive, here it's negative. Here the 2 is negative, here it's positive. They're exact opposites of each other. So when you divide that, you're not really canceling the x and the x, or the 2 and the 2, you're canceling the whole thing, and you're getting the x minus 1. So that's multiplicative inverses by definition there. So let's move on to why I gave you that, because I reminded you of it for a reason. So here we have a rational expression, algebraic equation, or algebraic fraction that definitely needs factoring. Definitely needs factoring. So let's look at the factoring. In the numerator, is there a greatest common factor? Yes. His name is a to the 4th. So I'm going to take a to the 4th out of both of those terms. Take a to the 4th out of the first term, you have a b. Take a to the 4th out of the second term, you have a minus 2. Second fraction, or the denominator of the fraction, is there a GCF? And the answer is yes. They have an a in common. Where is it found the least? A cubed. So we're going to take out an a cubed. Take an a cubed out of both terms. Take an a cubed out of that, you have a 2. Take an a cubed out of that, you have a minus b. Okay, a couple of points to make. First of all, the a to the 4th divided by a to the 3rd would be a to the 1st in the numerator, because it's heavier in the top. And these two are opposites. Positive b, negative 2, positive 2. When you cancel them, you get negative 1. So you got negative 1a. That's the answer to that question. And you can see where they did their dance in here. They actually wrote in the negative 1. But they got the negative a, just like we just did. So this is just an example of the same. And now we're going to look at multiplying and dividing rational expressions. Fractions, multiplying, dividing fractions. We've done that before. So if this was elementary school and we were multiplying these two, then we have two options to how to do that. One is we just multiply straight out. That's 6, that's 15. Those reduce because they both divide by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And you have that. An easier or a different way at least of doing that is to go, whoa, well, them threes cancel. And I get 2/5. That was what we did in elementary school. Well, we're doing the same thing here, except we're doing it with algebraic or rational expressions. So I'm going to rewrite the whole problem so that we have the original problem clean and harassed or messed up here, unclouded. Now, we just did that cross-canceling thing. So is it pretty obvious to you that 7 will divide by 7 and 21 will divide by 7? Is it pretty obvious to you that 8 and 16 both divide by 2, 4, 8? You want to use the largest one. So 8 divided by 8 and 16 divided by 8. Pretty obvious. What about the x in the numerator and the x cubed in the denominator? Those will cancel, right? But it'd be x squared in the denominator because it's heavier in the denominator or in the bottom. And similar kind of thing we get with the y cubed and the y squared. It's going to be y to the first, isn't it? In the bottom. So that cancels, and that's y. And then my final answer, I look at all my stuff in the top, I get 1s. That's all I got, 1. Look at all my stuff in the bottom, I get 6 x squared y. That's cute. All that mess simplified to this. Now you could have actually come up here and did the 56 x y squared over and then done the multiplication here and then done reducing, but to me it's easier to do that. Don't pay attention to what they did right there, it's awful. But that's right. That's what we got. Okay, so division of fractions. Again, you remember from elementary school, we don't divide fractions. We do that Kentucky Fried Chicken thing, or that keep, flip, change, or keep, change, flip, or whatever it was they taught you over there in that building. So we don't divide fractions, but what we do is we keep the first fraction, change the multiplication, and flip the second fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. After you've done that, like that little dancey step, after you've done that, then the rest of it is just like what we just did. It's that, because you're multiplying fractions. So we're multiplying fractions, and we look for things to cross cancel. And you can see the 10 and the 5, hopefully. You see that pretty easy, the 10 and the 5. And the 3 and the 6. The 3 and the 6, both of them divide by 3. And then you might go further and see that the c squares cancel. Gone. And you might see that the m and the m to the 5th would be m to the 4th in the bottom, because it's heavier in the bottom. And then you might see that the d and the d squared will do a little canceling, reducing. And it's going to be d in the top, because it was heavier in the top. Now the k doesn't happen to cancel to anybody, because there's no other k's in our problem. So numbers, 2, 1, 2, 2, 1, all multiplication would be 8. And then you've got the d and the k squared. And that's the stuff in your numerator. In your denominator, you got all 1s. I'm not going to write the 1. I'm just going to write 1 m to the 4th. So it's 1 m to the 4th. And that's the answer. No other reducing, canceling, nothing else you can do. Great. So again, they changed theirs to multiplication. They flipped the second fraction. And they're doing their little work here. And they got the same answer that we did. They put the k squared before the d. I don't understand that, but they could be wrong if they want to. So these are just practices of the stuff that we just did. So I wanted to get to this, because to me this is where we start getting into the algebraic skill set that you're going to need from Algebra 2 going into your pre-calculus. Because this is the stuff you do on a regular basis in calculus, is you manipulate, you use factoring, you use all these different arithmetic applications into algebra of multiplying fractions, adding, subtracting fractions, that's coming, all that. So we look here and we see what we have is a multiplication of rational expressions, algebraic fractions, and the second fraction happens to have parts that are not factored. So the first thing we need to do is factor. Now the first fraction, those parts are factored. You can't do anything with the k minus 3 and the k plus 1. So we just keep them, hold on to them, and move along. The second fraction, though, both of those will factor. The first, for the numerator, no GCF, but it is a special case because that's the difference of squares. So we got the owl winking at us. With the 1 and the k in that order, please. You may remember that we talked about that. You got to put it in the right order. And that's going to matter here because 1 minus k is going to be different than k minus 1. They're opposites of each other. So this one, no GCF, it's not a special case because that's not a square, so it's not a perfect square trinomial. But the leading coefficient is 1, so that's the easy kind, double bubble, k and k. And if you remember, signs are the same, they're both negative. And factors of 3 whose sum is 4. Great. So a little factoring. That's why I told you before, if you can't factor, just kind of out of luck because we keep seeing it pop up. And you will, if you're seeing it in algebra 2, you're definitely going to see it in the future because they're kept trying to get you ready for the future. So once we've done all our factoring, this should be pretty easy to cancel, like the k minus 3. That should be obvious to you. The k plus 1 and the 1 plus k, those are exactly the same. The k was positive in both cases. The 1 is positive in both cases. They're the same. They're just written in different order, but we have commutative property of addition, so we can easily change that. These two are not the same. They're similar. They're opposites, in fact, because here the k is positive, it's negative here. Here the 1's positive, it's negative here. So when you cancel them, you actually end up with negative 1. That's the answer. That is the answer. That becomes this. And if you're doing work in pre-calculus, stuff like that, and you're doing some problems where these kind of things can happen, and you can simplify craziness down to something like this, and then use it for something else, man, that's super. And that's what we're trying to do, is prepare us to this skill set. So you can see, look how cute theirs is. But they got the negative 1. Same thing we got, they got the negative 1. This is division. So what we're going to do here is we're going to keep the first fraction, change the multiplication, flip the second fraction, right? Because we don't divide fractions. So we can do that Kentucky Fried Chicken stuff. But while I'm doing it, I'm going to be observant or aware of the fact that that's got a GCF, his name is 2. And that is going to be the easy kind. I can go through the whole process, but that's the easy kind, double bubble, D and D. Signs are different. Factors of 2, whose difference is 1. It'd be 1 and 2, where this has to be the 2 and this has to be the 1. 2 has to be positive, okay? And if you don't know how to do that, Lord help you, go watch a video or something. Remember, we're flipping this one. So the D plus 3 is going to become the denominator. This is going to be the numerator, but I'm going to go ahead and factor it because it's going to be double bubble, D and D. Signs are the same, they're both positive. Factors of 2 whose sum is 3, 1 and 2. So once we get everything flipped, changed, factored stuff, then I start looking for things that will cancel. And the D plus 2 with the D plus 2, and that's it. Because these two things won't cancel because they're not opposites. They're just different. So they don't cancel. So I've got the 2 times the D plus 1 over the D minus 1. There may be some answer you see sometime where they go ahead and redistribute the 2. I wouldn't do it, but you need to be aware if you see an answer where the 2 is distributed, hey, that's the same thing I've got in this form. Yeah, they didn't distribute their 2 either, so good. So these would all be the same. There's examples of the same stuff that we just did. And this is the last problem we're going to do, I believe. And this is complex fraction. It's a fraction whose parts are fraction. So I'm going to put this big fraction bar here just to exaggerate what was already there, just so that we can see it's a fraction who has a numerator that's a fraction and a denominator that's a fraction. And so I've had students look at, there's no way we can do this. No, there is a way we can do this. First of all, do you agree that fractions is division? That's what they are. Fractions are division. So what this really means right here is x squared over 9x squared minus 4y divided by x cubed over 2y minus 3x. Now that awareness that fractions are just division is the key to that. Now, it's just the division of fractions, which we just did. And we talked about how that you keep. By the way, that's the difference of squares. I'll come back to that. You change and you flip. So the only thing I got to do is deal with this difference of squares. I said that's what it was. Double bubble, different signs, like an Allen winking at you. That's a square because that's 3x squared, so 3x and 3x. That's a square because 2y squared, so 2y and 2y. Hopefully you can see that okay. And so you can hopefully see that these two here are opposites. See them? That's a negative 2y, that's a positive. That's a positive 3x, that's a negative. These are opposites, so when they cancel, they give me a negative 1. And then the x squared and the x cubed would be x to the 1 in the bottom, because it's heavier in the bottom. And all in all, in the top, I get a negative 1. And then the bottom, I get x times the 3x plus 2y. That's it.